Hello everyone. Today we're going to be talking about symmetrical property of equality. I do want to say there are many other symmetrical properties like ones you use for your geometry and so on and so on, but today we're just going to be talking about equality. And I have other videos explaining more about other properties and more symmetrical properties, but just for today we're focusing on the equality side of symmetrical property. So I'm going to be here. I'm going to guide you step by step, and let's just go right into our lesson. So starting off, it is important that we know what symmetrical property is. And to simply put it, symmetrical property is where we can look at the equation from either side of the equal sign and simply swap their places. It wouldn't cause a result of change in our equation, and the equation is still true at the end of the day. This is essentially what the symmetrical property shows. It shows how you can move around your equation and still get the same thing. It's very similar to other mathematical properties that I go over. So check out my playlist that I've provided to check out more similar mathematical properties that you can even use in like your proofs for mathematical assignments. But going back to this, symmetrical property is just where you can look at the equal sign and simply swap the places of the equation. And here I have A equals B, then B equals A. So all I did was swap that A and B on either side of the equal sign, and they are still the same equation at the end of the day. This is simply what symmetrical property is. There's nothing more or less to it. This is, and just to reiterate, this is of the equality side. That's it, just so you know. This is not the geometrical side yet, but I will make a video on that. Anyways, moving on, let's do some examples together. So my very first example asked me, using symmetric property, solve the following. If 5x minus 20 equals 30, then which equation can be equal to this? So A, 20 minus 5x equals 30. B, 30 equals 5x minus 20. C, 20 minus 30 equals 5x. So remembering my formula at the very beginning, A equals B and B equals A. All I'm going to do is switch the values I'm given on either side of the equation. I'm just going to easily swap them just like that. So 5x minus 20 is actually going to go on the right and 30 is going to go on the left. So applying this, I see that B would be the correct answer. Now why wouldn't A and C be the correct answer? Well, starting off with A, I have 20 minus 5x equals 30. I kept the 20 minus 5x equals 30, so that equation is essentially the same as the original equation I'm given. I did not swap it. So yes, it is equal to, but it's not really what we're looking for when using symmetrical property. Looking at C, I have 20 minus 30 equals 5x. So I did switch the 30 to be with the 20, but that's not what we're doing. The 30 was on the right side, and so I would swap 30 by itself to go on the left side. 5x minus 20 have to be together because they are on the left side of the equation, so I would put that on the right. I cannot just take one value from one side and then put it over with the next and then swap one value out. That is not what symmetrical property is. The equation has to look exactly the same. You're just switching the places. So whatever your first half of the equation says and your second half, you keep them together, okay? And you just switch them, like A equals B, B equals A. So yes, B would be the correct answer. Going on to our second example, it says, using symmetric property, solve the following. If 9x equals 99, then which equation can be equal to this? So I have A, 99 equals 9x, B, x equals 11, C, 9x equals 10. So I know that A equals B and B equals A. So what I'm simply going to do is I'm going to switch that 99 and 9x. And I see that A applies this. It applies the symmetrical property formula. So A would be my correct answer. Now, why wouldn't B or C be my correct answer? Well, B has 11, and our original equation does not have 11 in it, so that's automatically incorrect. 9x equals 10. It has a 10. Our original value does not have a 10 in it, so that's automatically incorrect. And further expanding on B, well, yes, 9 And if you do 9 times 11, plug that x in, that x equals 11 in. Yes, you would get 99, but that's not what we're looking for. We do not have to solve or change anything because when you're solving for symmetrical property of equality, you are simply switching the values you are given around. You do not have to solve anything. I mean, you can if you want on the side, but it just won't be the correct answer. So that's why A is your correct answer because I simply swap the two values that I have on either side of the equation side. That's all you do. Going on my last example, number 3, it's asking me using symmetrical property, solve the following. If 90 equals 10 plus 10x, then which equation could be equal to this? So A, 90 plus 10 equals 10x. B, 100 equals 10x. C, 10x plus 10 equals 90. So I know that applying that formula, A equals B and B equals A, I'm going to look at my equation I'm given, very first given, and I'm simply going to swap that around. So 10 plus 10x will actually go on the left and 90 will go on the right. And I see that C applies this, so C would be my correct answer. Now, why wouldn't A and B be my correct answer? Well, starting with A has 90 plus 10 equals 10x. So while I did move the 90, I kept the 10 there. And since 10 and 10x are together, they have to stay together. I cannot swap one value out and then swap the other one. No, I have to keep what I'm given with together. You cannot just switch them, essentially. So A is wrong. B, I have 100 equals 10x. While that would be right if you were solving it algebraically, that's still not the correct answer because we are not making new values and stuff like that. You are simply switching both sides of the equation around. You are not solving for anything when dealing with symmetrical property of equality. So that is why C would be correct and why A and B are incorrect, essentially. So C is correct. Um, so what the really key takeaway here is you just look at both sides of the equation and you simply just switch them on both sides of the equal sign. That's all you're doing. You do not have to solve because this is just symmetrical property of equality. Okay, there are so many other symmetrical properties that apply for different things that might be a little bit more manual, and I will be making videos on that. So if you do want to check that out sometime in the future, go ahead. But yeah, that's all you have to worry about for symmetrical property of equality, essentially. So that's all for today, and I will be seeing you guys on the next video. This is Ari the Math Tutor, signing out. Bye!